Welcome to the Explainer. When we think about the most powerful weapons on Earth in the 21st century, it's pretty easy to assume we're talking about nuclear warheads or stealth fighter jets or maybe massive intercontinental missiles. But actually, the truth is so much more surprising. Today, the entire balance of global military, economic, and geopolitical power rests on something literally microscopic: tiny pieces of silicon known as semiconductors. These little microchips, they power absolutely everything around us. I mean, everything, from the smartphone in your pocket and massive data centers to electric vehicles and, yes, modern weapons systems. Without them, our modern economies would just stop. They'd completely shut down.
Okay, let's dive into this. At the World Economic Forum, Dario Amodei, he's the CEO of Anthropic, completely reframed how we need to be thinking about modern technology. He basically said, selling AI chips is like selling nuclear weapons. Let that sink in for a second. Microchips are quite literally the new oil. They are the absolutely crucial, scarce resource that the entire modern world depends on. But unlike oil, which you can pump out of the ground in dozens of different countries, computing power is now this massive strategic asset with profound military implications. So who gets to buy, design, and actually manufacture these chips? Well, that control is actively reshaping global geopolitics as we speak.
Chapter 1. Origins of the Silicon Age. To really grasp today's semiconductor arms race, we actually need to realize it's a direct evolution of Cold War military strategies. So, to understand how a tiny piece of silicon dictates global power, we've got to look back. The whole story really kicks off in 1947. That's when Bell Labs invented the transistor right here in the US. Pretty soon after that breakthrough, engineers figured out, hey, we can actually place multiple transistors onto a single silicon chip. Boom, the integrated circuit is born. Fast forward to the Cold War, and you've got the US and the Soviet Union pouring massive amounts of money into advanced self-guiding weapons. And that early arms race, it was fundamentally driven by a race for computing power. This whole fast-growing industry popped up in California, which, you guessed it, birthed Silicon Valley. But then, as we roll into the 2000s, there's this massive shift. You see, to maximize efficiency and cut costs, the US started outsourcing the incredibly labor-intensive manufacturing side of things over to Asia. The US kept its huge lead in chip design, sure, but over the decades, the actual physical manufacturing, that just kind of slipped out of its grasp.
Chapter 2. The Fragile Global Supply Chain. And this decades-long shift is exactly what created one of the most interdependent, deeply complex, and frankly fragile global supply chains we have ever seen. Let's move to and see how this builds, because unlike oil or coal, making semiconductors involves multiple extreme choke points. It's like a wildly complicated relay race. Step 1, a chip might be designed in the United States. Okay, simple enough. But step 2, that requires extreme ultraviolet or EUV lithography machines to print the microscopic patterns. These machines are absolutely essential, and get this, they are made by exactly one company in the entire world, ASML over in the Netherlands. Step 3, the actual fabrication, the physical making of the chip, usually happens at TSMC in Taiwan. And then finally, step 4, the chip gets shipped off to Southeast Asia just to be assembled and packaged. It's wild. If even a single node in this global web breaks down, the entire worldwide production line just grinds to a total halt.
Now, what's really interesting about this slide is the staggering level of concentration it shows. Just look at that. Taiwan Semiconductor Manufacturing Company, or TSMC, produces about 90% of the world's most advanced logic chips. These are the brains that process information in all our top-tier devices. Just think about that for a second. 90%. One single company on one small island basically holds a near monopoly on the absolute cutting-edge technology that runs our entire global infrastructure. It's pretty mind-blowing.
Chapter 3. The Silicon Shield of Taiwan. So what happens geopolitically when you have that massive concentration in one place? Well, it creates a literal defense mechanism. This brings us to a fascinating concept you can see defined right here, the silicon shield. Because Taiwan is absolutely indispensable to global tech companies, its semiconductor leadership actually acts as a geopolitical deterrent. Think about it. Any military conflict or major disruption around the island wouldn't just be a local issue. It would immediately cripple the global tech economy on a massive, massive scale. Nobody wants that. And that is exactly why tensions in the Taiwan Strait attract such intense, constant global attention. It's why governments all over the world are watching the region so closely.
Chapter 4. Geopolitics and the AI arms race. Now, let's talk about the modern catalyst that's just totally supercharging this whole conflict.
You've probably guessed it. It's the sudden, incredibly explosive artificial intelligence revolution. Training these huge AI models, it requires just an astronomical amount of computing power. And this exact same advanced computing power is also the foundation for modern military strength. It's what drives quantum computing, major cybersecurity breakthroughs, and those self-guiding weapons systems we mentioned earlier. Because AI has elevated these chips to an almost weapons-grade asset, technology supply chains themselves have basically transformed into strategic economic weapons. It's a prime example of modern economic statecraft. We're seeing governments actively using sanctions, export controls, tariffs, the whole shebang, just to battle for technological dominance.
So the crucial point is, this arms race comes with a truly staggering cost. $400 billion. That's a 4 with 11 zeros. That is how much China has spent annually just importing semiconductor chips. To really put that into perspective for you, China actually spends more money every single year importing microchips than it spends importing oil. That is wild. And naturally, this immense reliance on foreign technology creates a massive vulnerability for Beijing. It's driving this incredibly urgent national push to bridge that gap and achieve total self-sufficiency.
And this brilliantly illustrates the escalating, high-stakes technological arms race we're witnessing right now. Look at the two strategies here. On one side, you have the United States implementing these really sweeping export controls. The goal there is to maintain its lead in computing power by restricting China's access to both advanced chips and the specialized equipment needed to make them. The U.S. also passed the CHIPS and Science Act, injecting tens of billions of dollars to try and rebuild its own domestic manufacturing. Then, on the other side, China is responding by funneling billions into state-backed companies and national industrial strategies, all to break its reliance on those foreign suppliers. It is a very direct, high-stakes competition for the absolute future of computing.
Chapter 5. The Future of Global Power. But looking ahead, Washington and Beijing are definitely not the only ones reacting to this super fragile dynamic. Both emerging and established powers around the globe are moving rapidly so they don't get caught in the crossfire. For example, the European Union has launched its own EU Chips Act, aiming for technological sovereignty. Over in India, their semiconductor mission is working incredibly aggressively to build up local ecosystems for chip manufacturing, design, and packaging from the ground up. Meanwhile, you've got Japan and South Korea investing heavily to secure their own domestic capabilities. Basically, what we're seeing is a frantic worldwide race to build fabrication plants, attract top-tier engineering talent, and secure absolute control over the supply chain.
Which really just leaves us with this one provocative question. Are we entering a fragmented AI Cold War? With nations increasingly treating computing power as a literal matter of national survival, experts are warning that the world could very well split into competing technology blocks. As countries scramble to innovate and lock down their supply chains, one thing is overwhelmingly clear right now. Global power? It's no longer just measured in terms of land or the size of your military or how much fossil fuel you have. Today, the entire foundation of modern economic and military strength is built entirely on silicon. Thank you so much for joining me for this explainer, and I'll see you next time.